Everybody, I'm Mason Earles, and I'm an assistant professor at UC Davis in the departments of Bio and Ag Engineering and Viticulture Enology. I'm also a co-PI on the AI Institute for Food Systems. So today I'm going to talk a bit about AgML and how we can potentially build an open framework for agricultural machine learning data, models, and evaluation. So I've heard many times, and I've thought to myself, what if we had an ImageNet for agriculture? And I think this is I try to reconcile this idea in my head and think, well, you know what, this is a pretty deceptively simple concept. Why is this so hard to wrap my head around what that would look like? It's because I start thinking, okay, well, agricultural production is highly variable, many crops, cultivars, environments, and management conditions under which it occurs. There's many different agricultural applications that have different sensor needs, all the way from red, green, blue standard imagery through depth, 3D geometry, multi and hyperspectral, and thermal imagery. We've got different agricultural applications needing different ground truth needs. So what is our ground truth? Is it image classification, semantic segmentation, object detection, or many different types of biological state estimations like yield or stress? At the end of the day, there are many potential objectives for agricultural machine learning pipelines that could be predictions now or in the future about water and nitrogen demand, disease pressure, yield, and so on, or even making some physical actuation in the moment, such as spraying, thinning, pruning, or weeding. Across many spatial and temporal scales are what we're thinking about how we're thinking about agricultural data, right? This could be ground-based, could be captured through a UAV or aircraft or even satellite. We have many different possible temporal resolutions as well that range from sub-second phenomena all the way up to interannual seasonal types of phenomena. Now, wrapping our head around what an ImageNet for agriculture would look like is tough, but it's really important because the agricultural machine learning community is rapidly growing, right? Here's the search terms in the Web of Science when I use machine learning agriculture or artificial intelligence agriculture. How many publications have been made in the last 10 years? We've had growth from 150 publications in 2012 up to more than 2,700 publications last year. If you track this out for the next 4 years, you'll see that by 2025, we expect more than 10,000 publications happening in agricultural machine learning just based on this simple search. So another observation is that there are a lot of agricultural machine learning data sets. Many of us here have produced a number of data sets. There are many great data sets out there, but they're not centralized and standardized, meaning we don't have them in one location and they're not ready off the shelf to be quickly integrated into my own pipeline. So it makes sharing and transferability of this data difficult and creates some friction there. So there's this great publication I've listed here that has 34 of these, but many more exist. Another important piece of information is that agricultural breeding and production machine learning models are pretty unique to agriculture, right? Often we have multiple sensor inputs, like we talked about earlier, ranging from LiDAR through thermal. And we might have many trait outputs we're trying to predict, just as one example, yield, quality, and stress response. This kind of multi-output, multi-input type of framework in the context of deep learning models and architectures is not off the shelf, right? It requires some level of customization. So here's an example that we put together for the autonomous greenhouse challenges this last year, where we had an RGB in-depth input, and we wanted to predict 5 different trait outputs, ranging from fresh weight through height. To do this, we really had to, and we achieved from the state-of-the-art results, but it requires some custom model building. That said, there's a lot of reusability potential here that we could reuse and create general architectures for agricultural machine learning that could be useful for more people that are trying to do this down the line. Another thing to think about is that synthetic data and label generation has big potential for agricultural machine learning. Here's a study that we did last year where we used 3D crop models from Helios, which is from Brian Bailey's lab at UC Davis. We were able to simulate RGB sensors, for example, and using domain adaptation, train a model to generate very realistic data sets and keep the labels of where the grapes were at, for instance. This is not an easy thing to do, and again, requires a lot of customization in the architecture side, but also in the ability, we don't have standard simulators out there for generating these kinds of pairs of synthetic data plus labels. This is another example I'll skip over for now, but it really is incredible what we can do and how much it can improve the data efficiency of our model training procedure when we use these simulators, if we have standard ways of doing it. Right now, there is no such standardization or common agricultural machine learning framework for synthetic data generation. So I think all of this underlies the confusion I feel when I try to think, what would an ImageNet for agriculture look like? So what we've tried to do is say, well, maybe we need a framework, right? Maybe it's not just a data set. Maybe it's many data sets. It's a broader thing. It is what we're calling AgML. And we think there's a need for common data modeling and evaluation in a broader framework context. You can see it here at our GitHub page, and we've made this open as a community resource where we want people to contribute and build the community. This is not just us. We want this to be a broader community effort. The idea is that there are three main pieces: the data, training, and evaluation. I'll kind of walk through what these different pieces look like. AgML is an open source Python library. It's pip installable, PyTorch and TensorFlow integration for those who care. And there should be various points of entry or levels of entry and abstraction for all types of users. So one thing we've done is taken, this is where most of the effort's gone so far, is making these public data sets in a centralized and standardized form. So we've got about 28, 29 data sets in so far and growing very quickly, where we can go in and a few lines of code, you can see what those data sets are. We've got some Python notebooks you can run through. And then when you download it, you can look at all the license, citation, and original source information that gets printed immediately and is saved with that data set. So we can try to get these data sets that everyone's created out there and used more. We have a synthetic data API we're working on by building a Helios 3D biophysical modeling back engine from, again, Brian Bailey's lab. This is in C++, so we kind of created a Python binding and interface for doing this and making synthetic data generation with data and labels easier and faster out of Python for everyone to potentially use. We're expecting to release that by March 1st, in 4 to 6 weeks. We're also using this data to pre-train models, release performance benchmarks, and then also release those pre-trained models for all these data sets so we can fine-tune off of these existing data sets that everyone's worked so hard to build. And then importantly, the metrics and validation frameworks are an important piece of this that we're still working on. So come join the AgML community. Here's some of the very active users who've been developing this. Come try it out, beta test it, and contribute your data to the AgML public data API. I think this is the biggest, most important piece we can do at first, is building up this data set. So it's not just one ImageNet type of data set for agriculture. We have many needs. Let's put them all together and think of ways to link them. So I want to thank the AI Institute for Food Systems for funding this research and look forward to hearing from all of you. Thank you.